All right, looking at number 6 from the worksheet from yesterday, worksheet 2. There's all the information. Let's see if we can use it. Remember, we use it in reverse order that we found it. So A, B, C, D, and then D, C, B, A. So working backwards, let's go up 2 first. Although, be careful, right? A and D kind of work together like B and C kind of work together. So up 2, but the amplitude's 4. So I don't want to go up 2 like way up here and then have to go 4 more from there. So I want to be able to get up to 6 without going way off my graph. So 1, 2. And that's my new center line. My graph's going to oscillate around y equals 2. Phase shift is left pi, and the period is pi. That's a good combination. But because the period's pi, usually we're thinking the phase shift, we shouldn't shift very far because we want to leave room for everything. But since the period is pi and the phase shift is pi, like I want to come over a pretty good amount because I'm going to need to fit all of the graph in between negative pi and 0. The cycle ends at the phase shift plus the period. That's one way to say it. So negative pi plus pi. So I'm going to end at 0. So I've got to fit my entire cosine graph in between negative pi and 0. So it made sense to go pretty far left for my phase shift. So again, you have to be careful and think ahead a little bit on how far you want to put your phase shift. You want to move it just a little bit, or do you want to move it a lot? It kind of depends on period and phase shift put together. Amplitude is 4, so that's the height of the wave above the middle line. So if I start at 2, 3, 4, 5, 6, it'll go up to 6 and down to negative 2. So now I've kind of visually got my window. I need my cosine to fit in between negative pi and 0. Left and right, and up and down it fits in between negative 2 and 6. And I keep forgetting to do what I want to do first, and that is do a quick parent function graph so I know what it looks like. So cosine excuse me, starts at 1 and ends at 1. So that's what the parent function of cosine looks like. So that's what my graph's going to look like. Obviously, it's going to be changed up a lot, but it's still going to have that same shape. So I will start at a maximum. So my starting is at negative pi. Like there's my new origin if you want to draw a new origin. I'll start at a maximum. This may be overkill, but some people like to map the points so they know exactly what we went to. So there's point A maps to A prime. Point B is the end of the graph. We said we would end over here at 0. We'd go pi away from negative pi. So that'd be right there. So that would be B prime if we're mapping kind of point to point. Halfway in between, there's a minimum. So halfway in between would be at negative pi over 2. There's a minimum, which would be 4 down from the middle line. So that would be point C prime if we're kind of mapping point to point. And then halfway of those, I'm not going to label them, but those are at 0. Not on the axis 0, but on the new axis 0. And those would be at pi over 4s, but I don't need to label them. I've labeled enough. So there's my first cycle of the cosine wave. For the second cycle, do you want to go left or right? Right. I think I'd want to go right as well. So I need to go pi more to get to the end of the next cycle. This is a nice one since the phase shift and the period like synced up. It worked out really well. So now I just want to copy exactly this picture over between 0 and pi. So we started a max, we ended a max. Halfway in between, we're at a minimum. Halfway in between there, we're at the 0. But 0 on the new axis, not 0 on the actual axis. And then we just continue the graph like so. That one worked out really well because the period and the phase shift were kind of synced up. So that one turned out pretty nice. Let's look at number 9. That was the other one we assigned. Right, so if you haven't done it yet, or if you are doing it now, check and see if your A, B, C, D are all correct. And then we'll magically make those appear in just a minute. All right, so let's use all of that stuff. Again, use it in reverse order. A, B, C, D, D, C, B, A. Vertical shift is up 3. Amplitude is 5. So again, be careful. Those kind of go together. So I don't want to put 3, way up toward the top and then have to go 5 more. So we'll say 3 is right there. That way I can add 5 to it and not be way off the graph. There's my new midline. No phase shift. You may not know it yet, but phase shift is probably the one you want to be 0 more than any of the others because it really messes with fractions and it just gets tricky if there's a phase shift. So we prefer there to not be a phase shift if we had our pick. Period is pi, so that means my cycle will end at the phase shift plus the period. So if I start at 0 and I go pi away, I end at pi. Okay. Be careful. Your cycle doesn't end at wherever the period is. The cycle ends the period away from where you start. This one, it so happens that we start at 0, so that makes it nicer. Amplitude is 5. 4, 5, 6, 7, 8. So I've got to get up to 8 and down to -2. And now I've sort of got this imaginary window, right? I got to fit the whole graph in between 0 and pi on the x direction and -2 and 8 in the y direction. I think it's a little overkill maybe, but that's sort of the window that my sine graph has to fit in. And so if you need to have popsicle sticks or post-it notes to kind of focus in, that's okay.
You just draw the little graphy thing.
The little starting point? Yeah. Oh, the parent function? Yeah. So the parent function of sine, let's see, the big difference is sine starts at 0, cosine starts at 1. If I remember that much, you can probably get the rest of it. So sine is the one that starts at 0, ends at 0, and does that. So I need to fit that into that little box I had earlier. So starts at 0. Well, starts at the new 0, or the new origin. A period away, we're at 0 again, because that's where we're going to start over. Halfway in between, be pi over 2, we're at 0. All right, I don't know that I need to label the points, but we'll do it one more time. And that's the order I do them in. The first one, the last one, and then the middle points after that. First one, last one, middle point, and then halfway in between A and C is a maximum. Halfway in between A and C is a maximum. We already know our maximum's up at 8, though, because our amplitude was 5. And halfway between B and C was a minimum, which is 5 away from 3. So that would be at -2. That's one cycle. Do you want to do the next cycle to the right or to the left? Let's do it to the left this time. So if I start at 0 and I go backwards another period, that would be backwards pi. So back to -pi. And again, I'm thinking I got to fit my graph in between 0 and -pi, in between -2 and 8. So I take my parent function and sort of mentally transpose it into my little box there. And again, the best way is point by point. So first point, so there's point A. I guess it would be A double prime, I don't know. But it corresponds to the other point A, so point B is, well, where it starts over. Halfway in between, we're at a 0. Let's see, this is going down, so there'll be a minimum right there and a maximum right there, because it needs to look the same. Don't flip it over the y-axis. Keep going with the pattern. Lovely graph there. All right, I feel like many of you are just following along and doing as I do them. I want you to try number 7. So you try number 7, and then we'll go over that one.
So we just put a 7 pi. Do I put one here? What? You can't get it. It's going to be the one that's up and down. That's like the makes sense? Yeah. So the middle between -7 pi, you have to subtract 5.
So there's the characteristics, A, B, C, D.
I literally did nothing. Yeah,
So amidst the arguments going on over here,
I asked a question.
let's go backwards.
Someone else went, Andrew has a question.
Vertical.
So what's your question?
I'm recording now.
Oh, I'm sorry.
That's okay. I should have warned you ahead of time. Again, find them in order, A, B, C, D. Use them in reverse, D, C, B, A. Vertical shift 0, so no change there. Phase shift right pi, period 8 pi. So we got to consider those together. So I don't want to phase shift way over here and then have to go 8 more pi away from that. So I think I need pi to be in pretty close, so that 8 pi away, my cycle ends at the phase shift plus the period. Some people like memorize that, other people write it, some people just use it, whatever. But I need to end it at 9 pi. So, and just so my scale is right, I'm not going to put 9 pi out there on its own. I'm going to count out to 9 pi. So 2, 3, 4, 5, 6, 7, 8, 9 pi. Amplitude is 1, so as high as I'll get is 1, and as low as I'll get is -1. So now I've got kind of the box to fit in the sine picture, which I keep forgetting to do first, but that's okay. So there's what a sine looks like. So I need to squeeze, or in this case stretch, that sine, stretch it out to be between pi and 9 pi. Well, starts at 0. Starts at 0. Although that's my new 0, I've shifted over. The end of the cycle is at 9 pi. That's another 0. again, I don't know. Does labeling the points help see what point maps to what, or you're fine? You're okay. In the middle, here's where the argument happened. In the middle was at 0. That wasn't the argument. The argument is what's in the middle between 1 and 9. So you can count, or you can do like a middle school average, like 1 plus 9 divided by 2. The average of 1 and 9 is 5. Or you could just count 1 pi, 2, 3, 4, 5 pi. And then you can kind of verify, well, that's 4 pi from both, so I guess I found the middle. So the middle point is on the 0. And then halfway in between, we're at a max. That happens to be 3 pi, but we haven't always been labeling that point, so you don't have to, but maybe it helps. Halfway between B and C is a minimum. Halfway between B and C is a minimum. And then I'm ready to sketch in my sine graph. And again, because we do a good job with our scaling, our pictures always look really similar, even though this was really stretched out because we went out to 9 pi. And the parent function only went to 2 pi. So yeah, those graphs look really close, but they're not as close as they look because the scaling is very different. All right, now I need to go backwards because I don't have any more room to go forward. And so if I start at pi and I back up 8 pi, where will it end on the other end of things? Negative 7 pi. So negative 1, 2, 3, 4, 5, 6, 7. So now I'll fit the same graph, the same picture in between negative 7 pi and pi. So we start at 0, we end at 0. Halfway in between, we're at 0. Ah, yes, another halfway point. Dare I call on the person? So, after some discussion, mild arguments, halfway between 1 and negative 7 is at negative 3.
That was not mild.
4 pi away from both. And then halfway is down here. Halfway is a max. And so there's 2 cycles of number 7, a sine graph. What's the domain of this graph?
A lot. No, 1.
Domain is the x values.
Yeah, 1 to
It's all real numbers.
It's all real numbers, okay? So don't lose sight of the fact that
I was actually thinking about the range.
the range would be negative 1 to 1.
Yeah, shut up.
The domain, even though we only graphed it from negative 7 pi to 9 pi, the domain goes forever in each direction. So don't forget that, even though we don't graph at all, because that'd take forever. We graph a piece of it. All right, next try number 11. Try number 11. Lots of stuff going on with number 11. A, B, C, D. Well, B isn't 2 pi, but the others are the same. And then again, we use them in reverse. Vertical shift to 0, so that didn't change anything. There's my imaginary dotted line already on the x-axis there. Phase shift right pi over 6, period 2 pi. So I want to start at pi over 6, but then I need to go 2 pi away from that. So 2 pi is a lot bigger than pi over 6, so I'm going to put pi over 6 in pretty close. That might not even be close enough, because my cycle ends at pi over 6 plus 2 pi. So adding fractions, pi over 6 plus 12 pi over 6 is 13 pi over 6. Now, rather than just put 13 pi over 6 out here, that might mess up my scale. Like, let me give you an obvious mess up of my scale. Like if I put 13 pi over 6 right there, well, clearly if this is 1 pi over 6, this is not 12 pi over 6. So my scale would be really messed up if I did that. So I want to count my way out there. I don't need a measure. I don't need a ruler. But I want it to be reasonable here. So 1 over 6, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 pi over 6. So I went a little bit further, but that's okay. The amplitude is -3, so I'm going to end up going between -3 and 3. My normal sign looks like that. If you want to draw a flipped sign, if that helps, there's my flipped sign. So I'll start at 0. I'll end at 0, ending at 13 pi over 6. Halfway in between 1 and 13 is 7. So 1, 2, 3, 4, 5, 6, 7 pi over 6. That's my middle point. Halfway in between 1 and 7, I can either count or I could just use the numbers that are there. 1, 2, 3, 1, 2. So it's be at this one. And normally that would be a max, but we flipped it, so it's a minimum. Halfway in between 7 and 13 would be 10. And again, normally that would be a minimum, but we flipped it, so it's a maximum. So there's my sine graph. One cycle of it. Pretty sure I want to go backwards to get to the other end. So pi over 6 minus 2 pi. What would that be? So where's it going to end on the other side? So pi over 6 minus 12 pi over 6 would be -11 pi over 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've got my start and my end. Halfway in between. Andrew, you're a halfway person. What's halfway in between 1 and -11? Good, 5. 1, 2, 3, 4, 5. So -5 pi over 6. Because it's 6 away from each of them. It's in the middle. Let's see. 1, 2, 3, 1, 2, 3. So right here at -2 pi, we'd have a max. And at -8, we'd have a min. All right, to me that's one of the harder ones because it was flipped, but mostly because the phase shift and the period had a weird combination. So it took a little bit of thought to figure out, well, where do I end and where do I end on the other side?